Welcome, everybody. So, we're going to discuss Java as an object oriented language. In the past, I have, maybe just to prove a point, I have maybe made the comment that's Java being a purely object oriented language. In the purest sense of the paradigm of object oriented languages, it falls short of that for sure. In relation to other languages, it's very object oriented. So it's probably farther down the line than C++, and it's probably doesn't fit it perfectly. But probably whenever the people that developed Java, they realized that if you wanted to follow the paradigm exactly being object oriented, things could be a little bit cumbersome, right? And so you'll find that a lot of things, even when you talk about parallel computing with a GPU, you find out that people break things as far as paradigms go in just the right places to not only provide it this like all the features that something may provide of a certain paradigm, but it also kind of brings it back to where it limits it from being overly cumbersome, if that makes sense. So there's all sorts of instances in computer science where we have this very pure notion, but the very pure notion could be a little bit cumbersome. Or, in all honesty, sometimes whenever we're developing things in computer science or language, whether it be a language, hardware, whatever, as things progress, we realize that maybe in hindsight, maybe some things should have took a different path, and so you'll see the development community try to steer it back to that path, but they have to take it incrementally. Or sometimes they do abrupt changes. Whenever Python went from version 2 to version 3, there was some serious breaking changes. If you look at Java over the years, sometimes you'll see Java 8 people refer to lingering around. Java 8, you don't see much prior to that because you'll find out in Java 8 that's where they have integrated some things or made some changes that made all the previous versions of it a little bit less like desirable and so deprecated that it's hard to maintain any reasonable modern implementation with it. So anyway, I still am aware that a lot of people still have Java 8 lingering around. All these major iterations of the Java language, you could see where they have like tried to steer a course in a certain way. So anyway, long story short, Java is not pure object oriented in the strictest sense. It's just kind of been broken in the ways to where it's highly object oriented, but not cumbersome either. All right. So what I want to do is I want to discuss today about class components. You guys are going to hear me say some things over and over, and I know it may become slightly annoying perhaps, but it's things that I consider important and that I really want you to be able to like say on demand whenever you hear somebody like talking about it. Like when you're at the water cooler, I want you to be very conversational in it. Okay, so the class structure in Java is going to look a lot like what you're familiar with from C++. Now, some of the syntax is a little bit different, but as far as the layout and the things and maybe some of the keywords that you're familiar with should be very familiar, right? If you're coming into Java without any kind of C++ knowledge, so like I teach a Java class myself, but I realize that there may be people watching these videos. I get emails from people saying, hey, I like your videos, so I encourage people to watch them. I'm always appreciative when people watch them. So if you're watching this because you want to learn how to learn Java, then you may not be familiar with C++. In that case, this you'll hear me make references to C++, but this lecture video should be enough on its own for you to understand what's happening. So I'm going to transition to my notebook real fast, and I want to write a few things down. Some things that I feel like we should be well familiar with, just to kind of get things under our belt. Maybe the layout, the structure. We're going to hop over here in a minute to the IntelliJ IDE, and we're going to actually do some actual coding here with a class, a very small class. But for right now, let me write a few things down. There's one phrase that I want everybody to know, and you'll probably hear me say it on every lecture video, is the word encapsulation. It's basically sometimes we create objects to basically hold a lot of information. If you guys remember, back when you send an email, there's two ways you can send an email. Let's suppose that you have this person trying to send an email to this person, and we need to send a bunch of files. So we have all these files that we need to send. Now what we could do is we could sit there when we click the little attach button to attach the files, we could sit there and hold our buttons on a keyboard and then start selecting multiple of them and then send it. And then you find out the server has complained because it only allows so many attachments, or the size of the attachments are not okay, whatever. So instead of having that, and then more importantly, whenever this person receives it, they've got all these file attachments that they're going through. So what we could do is, instead of doing that, and then I'll bring this back into the programming language in a minute. What we can do is we could effectively, for those of you guys remember, We could put all these in a directory, and then we could essentially do what? Zip that directory, and now all those files are in a directory that kind of act like one file. And so then you transmit that one single file. This has origins back to the tape drives with tar, with tar compression and everything else, tape archives, whatever. You basically jumble all this up into one file. Then you just basically take this container and email the container. Then when this person receives it, they receive the container as a zip file, and then what do? They decompress it, and then they have access to all the files, and it's in one nice neat directory, and we didn't have to go through downloading individual files. What I want you guys to think about whenever we talk about data encapsulation, that's kind of effectively the idea, is that we're creating objects that are going to hold a lot of information, and instead of passing that information around from one function to the next or from one endpoint to the next, we're basically going to send the object, and then whoever gets the object can use the object as they see fit, right? That's the idea. Now, there is one important difference. In the C and in C++ language, we do have something that we refer to as a struct, right? And from what I remember, whenever I was taking my compilers classes and all these things, C++, we all know it's a bit, this is a little bit abusive, but C++ we sometimes consider to be a wrapper of the C language to make it object-oriented effectively, right? Now, I know that's abusive. This is not a course for all this. We're just saying it out loud. So C++, you could make structs behave a whole lot like classes behave, right? You can make them behave a whole lot like that. It just takes a bit more work, right? Maybe a little bit. Maybe that's a little bit abusive too. But in C++, we also have something called a class. So in C, we have the struct, and in C++, we have the struct, and we have the class. And typically, if you just need to hold things, you put it in a struct. If you need it to have like variables along with things that you need to initialize, what do? You basically create a class. Now, Java is very much the same way, except that we really don't, let's just say this, we don't have that same popular thing that we call a struct. We just kind of go with a class, right? So in a Java, we typically just go with a class when we're encapsulating data. Again, this is meant to be overly simple, almost to the point of being abusive, because we're just learning how to program in Java, and we're learning about the paradigm of object-oriented programming. Whenever you start maturing and you start maybe taking your courses in compiler theory, and you have all these notions and conversations about topping and a few other things like variable topping, tops, strongly topped, all that, we're going to cover some of that. But when you start getting mature in that, you'll realize that you're going to be able to extend your knowledge quite a bit and be a lot more conversational in that. But for right now, we're just trying to give you the basics. So the Java class is kind of the basic object that we're going to be talking about. Similar to C++, I'm basically going to kind of draw a little box here to show you how it's going to behave. And like C++, it's going to have a whole lot of the same parts associated with it. So if you remember, let's just suppose that this is a Java class. This is just a class. We typically define our class variables up here. If we want to kind of keep our code nice, neat, and organized in a traditional sense, we're not talking about showing off all of our programming skills here. We typically put all of our class variables, everything that the class will need, in here. And then if you can keep in mind, back in the C++, we had this section that we called the public and then the private when we're talking about the header file. In Java, we don't necessarily have to do that. We're going to have maybe our public methods here, functions, and then we're going to have our private ones here. Now, depending on how you see the world, maybe you put your private ones first, maybe you put your public ones first. There's actually linting rules that will actually enforce that if the company you work for has specific ideas about how things should look. I think as long as you keep things kind of nice, neat, and organized, typically you are fine. But always keep in mind that the organization you work for may have some opinions about the way things look, and they may include what's called linting rules to whenever you pass your code from one development environment to the next, it may check to make sure that you follow those linting rules, and it will throw out errors if you haven't. Naming conventions for variables are sometimes linting rules, like some people like camel case, some people like snake case. They can actually develop rules inside of the code promotion and the development environments to make sure that you follow those conventions. Now, they get a little bit clumsy sometimes, but they're pretty good unless you start just maybe trying to break them. All right, so class variables in C++, if you guys remember, these things could be public, or they could be private. That's the same way it is here. Now, in C++, we also had other keywords that we could assign. Java's the same way. We're just basically trying to get that basic class understanding underneath our belt. Public variables are where we can access things outside of the class directly. Like we can make changes to variables inside the class without having to go through a method through public. Private means that only the methods inside the class can make alterations to them. Same way with this. Whenever we have methods inside of Java, we don't necessarily have special designations like over here in the header class C++, where you have that public colon, then you have the private colon. We don't necessarily have to have that in Java. Instead, what you'll do is you'll just declare it public or private, and then try to organize it in a way where all your public ones are together, your private ones together. Sometimes you might mix and mingle that if a private method is only associated with one public one. It depends, right? Everybody's got an opinion about programming. If you encounter someone that says, this is really the only way of doing it, and they have very super strong opinions, they might be valid. They really very much might be valid, but just keep in mind, every language has kind of a set of norms that they consider to be appropriate. Inside of a language, you'll typically see the C people behave differently than some of the Java people. Even the way they use snake case or camel case, you can see that vary between languages. So there's actually entire websites, and actually, if I'm not mistaken, a few publications to where you could actually look up what are the norms associated with the Java developers, what are the norms associated with the C++ developers. I actually had a teacher whenever I was in grad school that actually required us to look up those norms and follow those norms whenever we had a specific language. All right. So we could talk about whether that's good or bad. It's generally anything that makes you more aware of what's happening is generally valuable information. Anything that makes you more aware of what the common norms are, the more you try to conform with norms, as long as they're not just like strange or counterproductive, it's typically best to keep things in a nice stable fashion. So that way everybody that's reading Java code to the next developer to the next, they kind of have a common understanding. It's usually very valuable to do that. So anyway, like I said, a class, we have the variables. The methods, we have public and private. Very much like the variables and the methods associated with the C++ class. It won't be until we get a little bit farther into like our learning of Java that we'll start seeing where things really break off. The syntax will always be different. The keywords in some ways will be alike, in other words they'll be different. It's almost though like the Java people, whenever they were breaking the purely object-oriented paradigm, they realized that people like C++ is something from the 70s perhaps. Java is something of the 90s, year-wise, by the way. It's almost like the Java folks knew that there was a lot of C and C++ people that had knowledge, and so to make a language get adopted, to create a language that gets adopted quickly and help out with the learning curve, the more you can make it look like something that's already well established and works very well, the better off you'll be, right? There's a lot of languages that you'll find that had kind of a good groundswell initially, but they just didn't seem to hold on. And some of that probably has to do with the structure of the language. Like they use symbols and they use notations to where, like, if you're going to have polyglots, they had to cram so much in their mind to where they don't have to remember just distinctions about the language. They have to memorize the entire maybe structure of it. It becomes cumbersome. So anytime that you can make things kind of look like something that people are already well familiar with, the better off you'll be. And you could certainly see that in the Java language. I think that's very fair. Like the way you declare an int, it's still int. The way that you do like methods inside of a class is still the dot, just like they had in C++. They're very handy things, right? All right. So what I'm going to do is I'm going to transition now over to the repository that I created. So let's start looking at code. Right now, what I'm going to do is I'm going to show you. At the moment, I created a repository that's going to hold this class code. So at the end of this lecture, I will send you guys out, or I'll make it available in the comments, or if you're in one of my classes, I'll send an announcement. I'll basically send you the GitHub link to where you can bring it in and see what I've done, and you can play with it on your own. But what I did is effectively create an empty repository that I'm going to create for Java code. I'm going to click the down button. So again, I want you guys to notice there's absolutely nothing inside of here. It's absolutely empty. It's got a README that's got nothing inside of it. The get ignores there for Java, whatever. And then the license MIT, I just selected that. So let's click the down arrow, and I'm going to do this because I'm going to need to use this to push it whenever I'm done. Now we're going to go over to the terminal. I think I already had something in mind here, but this is not right. I'm going to go to the terminal and I'm going to paste that, git clone, and then I'm going to do that. And effectively what that does is that brings it into my local computer, right? So if you guys are not, if you're watching and you're not familiar with GitHub, if you're one of my students, you have to know it. If you're just watching to learn Java, this is not necessarily important. You don't have to do this. Again, now the next thing that we're going to do is we're going to go over to IntelliJ. IntelliJ is basically a very, very, very useful IDE with Java. There's a whole lot of people that talk about being developers and they only use VS Code. That's okay, but keep in mind there are languages that have some quirks to them, especially in the virtual environment that Java finds itself operating in, that IntelliJ is a super hyper form of it. Also keep in mind that whenever you're doing development, you may also be developing Java to be used in a certain cloud environment, and then you've got some opinions and some methods and some manners that you have to keep in mind with that too, and IntelliJ makes that very easy to do as well. VS Code has those kind of extensions, but when it comes to Java, 100% IntelliJ kind of eats the lunch of everyone else. Now, I want everybody to be clear. This is where we talk about maybe the people that twist the mustache and they talk about how I only program in Vim or I only program in Emacs. All that's fine. And to be honest with you, I very much find myself going to Vim and Emacs a lot. I know all the tricks of Emacs, and whenever I was younger, I was strictly Vim and Emacs totally. Whenever I was a math teacher in math departments, I was Vim and Emacs only. It wasn't until I started working in industry that I really started seeing that if you're going to stick to just Vim and Emacs, you really almost start creating an isolated environment. And you almost find it hard to start incorporating what you're doing with everyone else, because whenever you're having your team meetings and your project meetings and you're demonstrating code and everything else, you find that getting your environment up to where everybody can see and interact with it and see what's happening, you end up finding out it gets a little bit clumsy and everybody has to wait on you during the team's meeting and whatever else. And then when you're sharing code, everybody has to be like, okay, well, we'll do this. And then we got to do it through the AWS to link it up, or the Azure, or whatever else. So those folks that say, I only use Vim and Emacs, they might just be that well familiar with it. There's also another chance that they may not have been exposed to extreme development environments either. So with that said, or they might not have worked for an opinionated employer that says, you know what, we need everybody to be doing this so we don't waste time with having everybody having distributed ideas on how they present things. It's whatever kind of one of those things, whatever your boss wants is kind of what you get, right? Type thing. So you can either fight it or you can do it, whatever. All right. So what I'm going to do is I'm going to open up my repository that I just actually, no, I'm going to do a new project. Let's do that. New project, because my repository is empty. And I'm going to do intro to classes. I'll just name that my project. And I'm going to put it in Maven here. Here, I think I want to do OpenJDK 23. Don't know, just a selection here. I'm not going to put it here. I'm actually going to go over and I'm going to select my GitHub repository that I put this in. I think I put it in teaching. Here it is. So basically, I'm just going to open this folder, and you guys don't have to do this at all. So basically, I'm going to click this add sample code, generate code with onboarding tips, whatever. We'll just leave that alone. This, just leave alone. And I'm going to click Maven. Maven's a good starting point. It won't matter for this lecture, actually. We're going to click create. All right, and you see IntelliJ's kind of ramping everything up there, and effectively, we are all set. There's no errors. IntelliJ's not complaining about anything. We seem to be ready to go. All right, so this is the POM file. For this class, for this lecture, we don't have to touch this at all. That's just completely not relevant for us right now. We'll turn off this breakpoint, and what I'm going to do is I'm going to highlight everything inside of this main, and I'm just going to delete it. So we have something just brand new start. When you create a class, this is what I want everybody to be aware of. I've actually got disable completions for the time being. So whenever we got this class, we typically give it a name. Whenever you have a name here, it needs to match the name of the file here. So I want to show you guys what happens. Let me just rename this to something else, refactor this. I'm just going to rename this to, I don't know, let's think of something cool. Nathan class. How about that? Notice that it renamed it over here as well. And I don't know really what all is happening here. Let's just take this off. This right here is effectively the name of the file. See how it's got up here? All Java source code has .java inside of it. The name of the class has to match the name here. So here you're declaring a public class, and it'll be very much similar to what we call public and private classes like in C++. Public just means everybody can use it. Private means it's a bit restricted somehow. Then we have Nathan class. That was the name of it. For right now, we can ignore this. This is just anytime you're in a package, which IntelliJ creates automatically, and you probably want to be in one, you have to declare the package. So for right now, just forget that because IntelliJ will handle that for you for the time being. If I was to somehow maybe rename this class, and I'm going to say refactor, and it's going to allow me to have the option to rename the file. Let's suppose I'm going to say, let's just call it Nathan over here, and then I click refactor. Notice that we now have a red squiggly line here, and then all of a sudden this arrow pops up, and the reason this is happening is because IntelliJ is a bit confused. Maybe it thinks we're defining a class within a class. Who knows what it thinks we're doing? It just shows that this is not. So if you're ever working on assignment and you're able to see this little arrow next to a file and you see red lines underneath it, check to see if maybe the name of the class does not match the name of the source file. As you can see, I've got the problem here. So now I'm going to go back and I'm going to click rename file, and I'm going to say Nathan class. And notice how it no longer is complaining. The idea, let's boil it down to something simple. Every source code file ends in .java. The name of the class needs to match the name of the class here. The file name has to match the name of the class. Now, in your class, the starting point, if you guys remember back in C++, the starting point for your C++ program was the main function. Remember, we had a function we called main, and that was kind of like the starting point. In Java, there's something similar. Remember how we said Java is a slightly more pure object-oriented language? In Java, you have to kind of start with a class. You're effectively in a class when you start with Java. You're basically just going to define a name of a class, but the point where you're going to be like starting from is also called main. So if you create a class and you want to determine which one of those methods is going to be called whenever you run the program, it has to be the one called main. Now, what do we know about C++ and C? It's very similar to that. They have this main function where they're going to be starting off from. See how I said about the Java people, it appears that they kind of wanted to make it familiar to people. So main is the starting point. Here's almost always what you'll do. For right now, you'll probably always declare a class. And if you're in IntelliJ, it'll always create this for you. And it'll probably always create this for you. But if you want to rename the class, it will almost always be public class. This is where you're defining it to be a class. In Java, there's all sorts of other classes. I'll show you if you want to create a new Java class. There's different types of them. There's an interface, there's a record, there's an enum, there's an annotation, and then there's an exception class, right? So what we're pretty much going to be dealing with a lot with this class is the class, interface, record, and enum. We'll dally around with the exception. The annotation we're going to kind of glaze over just a bit, but you have these various classes. And whenever you're declaring one, you'll say, oh, public enum or public interface or whatever that you got, and that'll be letting Java know what kind of class it is. So right now we're kind of creating the traditional one. So that would be effectively how this is created. Public class, Nathan class, that's the declaration. Everybody can use it. This is saying that it is a class. That's the name of it. Now in your main function, the one that's going to be like starting off, the one that's going to be like running from scratch whenever you hit the play button, it's going to be public, static, void, main. All of that has to be there. In order for it to be the driving function, it has to be called public, static, void, main. Static just means that it will run without the class being initialized. Public means that it's available to the outside world. Void means it's not going to return anything, and then main is just the name of the method that's going to be running initially. You probably want to put this in here. String, you're going to have an array of strings called args. If you guys remember in C++, you always had that kind of arg parameters there. You had 2 or 3 of them out there for args. It's kind of very much the same thing. In fact, it's ARGS, which is typically common with the C language as well, right? C++. Like I said, the Java people wanted to make it familiar. And then everything that's going to be inside the class is effectively going to go here, right? Now, since we're in the main one, this can be the part where we're writing sequential stuff where the program is going to be calling everything else. So what I would like to do maybe is let's create another class. Let's say we're going to create a Java class and we're going to call it sample. How about that? Now here, what I recommend is you say don't ask again and click cancel, because that's where IntelliJ is wanting to help you out by saying you've added a file. Do you want me to stage it for you? Don't do that. You can do it yourself. So does everybody agree that we're in this package called example? Notice that this thing's doing that for us, IntelliJ. Good. So we're creating our own class. The reason this class exists is because this is going to be our starting point with the main function. This class does not need a main function because this is not going to have a starting point. We're going to be calling sample from inside our main over here. So let's go ahead and build our sample class just so we can get an idea of it. What do we say we do whenever we have a class? Well, we make sure this is off so we don't have this. So what do we do in a class? Well, we typically define our what? Our variables, correct? So what I'm going to do is I'm going to say private, and I'm going to say first name. Actually, that's not a good way. The Java people tend to prefer this. All right. It's got a little bit of a problem. Let's say we're going to do age. We're going to say int, and we're going to give it our age. Okay. Now we're going to do this. I'm going to say public int, and I'm going to say, I don't know, fake age, perhaps, right? So that's what we have. This is the only thing that we have in our class. Now we're going to go over here to Nathan's class, and I'm going to go into my main function, and I'm going to basically say that sample. Do you see how it's kind of helping you out? It's giving you that sample. Then I'm going to do dot. Sorry, excuse me just for a second. We're going to have to give it an instance of it. I'm going to say my sample class. Excuse me just for a second. I apologize. I was having a little bit of buffering happening there. I apologize for that. Sometimes when I'm recording videos, I'll have a little bit of mishaps happen, so I apologize about that. So we're going to say equals, and we're going to say new sample. Okay? So what I've done here is I've given it a type. I'm saying that I'm creating an instance of my sample class, and I'm doing new sample. So now I've created one of my sample classes. So I'm going to say my sample dot. Now here's what I want you guys to see. Notice that fake age is populating, but age is not. Age is not populating. Why is that? Age is private, which means that only things inside the class can access age. Things outside of the class can access fake age. All right, so what I could do is I could actually set fake age to be this value where I say maybe it's going to be 5, or let's say it's 35, correct? All right. No big deal there. So what I can do is I could go over here and I could actually create a method to where I'm going to say public void, let's say print fake age. And all I'm going to do is just simply do system.out.println, and then I'm going to say this dot fake age. Okay, so whenever I have set this, I could basically call my sample class dot print fake age. Notice that it's there, and now I'm going to go over here and I'm going to hit the run button. It compiled it, and notice what it's printing. I set the age to 35, and then I said let's print it. And the reason those things are available is because this method is available as public, which means that things outside of the class can actually access it. Now what I'm going to do is I'm going to create a private method where I'm going to say private void, and I'm going to say increment fake age. All right, I'm going to say increment fake age, and basically what I want this to do is I just wanted to say this dot fake age. That means just take the fake age and add 1 to it. Now, notice that I won't be able to call this function. So if I go over here and I say my sample dot increment, you see how it's not there? Let's see, let's make sure. It's called increment fake age, but it's not able to be used, right? We can't use it. So let's see, how do we use that? How can we make this work? Well, what I could do is maybe I could now make this public. I can go back over here and I could do increment fake age, and notice that's here. And then what I'll do is I'll do sample and then print fake age again. So if this is working the way I think, I've set my fake age from outside the class, and then I'm going to print it. Then I'm going to increment it. Then I'm going to print it again. So what I should see is that this sets it to 35. This will print it out as 35. This will add 1 to it, and this will print it out. So let's see if it works. Okay, so notice that the first print printed 35. Notice that this one printed 36, and that's kind of what we expected, right? Now, here's the problem. I want to show you guys why is it making variables public a problem. Notice that we're just going to say fake age. I don't know. I got my real age, and then I got the age that I tell everybody else, right? So maybe inside of here, I'll let's leave this alone for a second. Let's suppose that fake age, how about we do this? Let's suppose that I mean to type in my real age is like 38, but I accidentally do this. Now, we've declared this as a what? We declared this as an integer. The problem is that negative 38 is an integer, but you know, if we think about it, negative 38 is not quite a good integer for age, right? Something about that doesn't quite hold up, because when you have negative values for how many years old you are, I mean, that doesn't make a lot of sense, right? Okay, so the problem with making variables public is that you don't have a whole lot of control over how people will set the values. So maybe what we'll do is we'll create something called a setter. I no longer want somebody to do I no longer want somebody to be able to set the fake age from outside the class. I'm going to make it private. So that way, the only way fake age gets set is either through something we call a constructor, we'll get to in a second, or it has to be through a function in the class. So what I'm going to do is I'm actually going to do this. I'm going to say public void set fake age. Okay, so I'm going to do that, set fake age, and then I'm going to put int age. Okay, and then I'm going to open this up. Now, what I'm going to do now is I'm going to say this. If let's suppose if age is less than 0, if age is less than 0, or if age is greater than, I don't know, what's the oldest living human being? I have no idea, maybe 120 years old. If age is less than 0, or if age is greater than 120, then what we could do is we could just make it say, well, fake age equals 0. Now, here's what I want you guys to notice. Do you see where I have this here, but I didn't use it here? Anytime that there's no possibility for like ambiguous definitions for the word fake age, you could actually just make it reference this. Now, let's suppose that the parameter that I'm passing in is called fake age. Now the problem exists. When we say fake age is equal to 0, we don't want to do that, because in the next line, what we're going to have is we're going to say fake age equals fake age. I don't know why I keep hitting the same thing over. Now this is a problem because it doesn't make sense. Maybe I want this fake age to be this parameter, and then this fake age to be this one. The idea being that I've got a class variable that I need to set using what we refer to as a method called a setter, which is where we add restrictions. So take a look here. if age is less than 0 or if age is greater than 120, then what do? Maybe we set it and then we're going to issue out a command to let the user know .out.println. Now later we'll do exceptions, but for right now this is what we're going to do. We're going to say invalid age, and then maybe we could put the issue failed, right? We'll do exceptions later where it causes the program to exit out, but we're not quite there yet. So let's take a look. We no longer want somebody to access the fake age from outside the class. So what we're going to do is we're going to create something called a setter. A setter is where we handle setting the class variable, but what a setter allows us to do is allows us to control what we allow users to set. So we don't want to have a user set a negative value, and if we do it greater than 120, it looks suspicious. So what we're going to say is if it's less than 0 or greater than 120, we'll set the age to 0, then let this person know that it failed. And so it's been defaulted to 0, just kind of a placeholder. Now, here we got a problem. This parameter and the class variable have the same name. So which one are we doing? When we're doing this, what does it mean? The class variable has this associated with it because now we got ambiguous. We got a parameter named fake age and we got a class variable named fake age. So we can resolve that ambiguous situation by making this. The keyword this means this one inside the class. This dot something means refer to the one in the class. Now fake age by itself is this one. So what I need to do, I need to put this dot fake age equals fake age. This fake age is this fake age. This fake age is this one. Okay? Now if you notice, IntelliJ makes this very nice because it's make this fake age in white, which is letting you know that that would be this one, and this one is in pink, so that means everywhere you see this pink one, it's okay. Now I want you guys to be clear, inside this method there is no other fake age, so I could erase this and we still have the pink one. That's because anytime that there's no collision of like similar name variables, it will always go to the class which has been defined up here. In my opinion, just my opinion, adding the word this is always safer, especially whenever you're doing code development. Whenever you guys graduate through your careers and you start becoming senior code developers, you become like the people writing primary code and you become the kind of project managers, whatever. Anything that you can do to prevent confusion for your younger developers, you do it. Because whenever younger developers create things, they tend to be very a high probability of bugs. So anything that you could do to resolve any potential bug problem, do it. Even if it doesn't quite show off your, even if it doesn't quite show off your coding skills or your coding knowledge, it's okay because it beats having things show up on your resume or things show up on your corporate review, say, well, there was a critical bug that this person caused, whatever else. So that happens. So anyway, anytime I make a reference to the class variables, I typically like to put this. Does that mean that I always will? Maybe not. But when I'm in development, I always want to create the least potential for a bug to sneak in or something ambiguous. Remember, these languages are very high level. These languages are very powerful. They can sometimes do things to where what they're actually doing is a bit different than what you may expect them to do, and it can be a little bit hard to debug. So if you're always intentional about what you're wanting to do, it's always safer. So let's recap. For the time being, let me just erase this because right now I got a class called sample where I've got my fake age in there. Initially, I wanted people to change fake age from outside the class. I no longer wanted to do that. Why is that? Well, because we don't have any controls on what they might set age. Age is just an integer, and from the programming standpoint, -5 is perfectly fine. But for a human, that integer may have extra restrictions. So here, notice I've got a problem here, by the way. Notice that I've got fake age here because I changed this to show you to show you the problem. This should be what? Fake age. This should be fake. Gosh, I can't type. I'm having to reach over my tablet here at the table, so I apologize for that. So we have fake age. Now these white ones are basically checking the parameter. If it's less than 0 or greater than 120, make it the default, make fake age in the class the default 0, but to let them know that it failed for some reason. invalid age failed. Otherwise, what do? You do this effectively. Now, when we do this, we probably need to do a return so that way the code stops there, correct? I'll overlook that. I was expecting to put an exception here. Exceptions effectively kill the program, so you wouldn't have to worry about the return. But for right now, all we're doing is printing a statement, so we just want to return. So if you end up in this body statement, it's going to set a default value 0, let you know to the terminal that something's a problem, and then it's going to return so this never gets executed. All right. Notice right here. All of a sudden when I change something, IntelliJ now tells me that I got one related problem. Immediately when you're using IntelliJ, I'm going to be honest with you, there's a lot of people that switch over to IntelliJ even for C++, because this proprietary IDE is very powerful. It very much is. I use VS Code for everything outside of Java. Java, I stick to this. Notice that when I made this private, it's popped up this one problem. Sometimes it's helpful. When I click this, it's going to make me go over here to Nathan class. Watch what it does. This is the problem. It's highlighted in red. Why is that a problem? Because I'm no longer allowed to set the variable directly. I have to do what? I have to go through the setter to do it. So watch what happens when I do my sample dot, and I'm going to say set fake age. Let's suppose I want my age to be 9, but I actually put -9. And then I run this program. Notice what the default value was. It says invalid age failed. What does invalid age failed method do? It sets the fake age to 0 as a placeholder. Then we get this. Then it increments it, and then we print it again. So basically it got set to a 0. Then our next one incremented it to a 1, and then it printed out again. Okay, so maybe I would now want it to be a 39. So if this works, what we should have is it prints a 39, increments it to 40, then prints the 40. So it worked out well, right? So what do setters do in a class when we're encapsulating data? You typically never want to have people setting variables directly. Now, for those of you guys, does adding functions add a little bit of overhead? Is it possibly going to add a few milliseconds in for loops or whatever? Absolutely. However, whenever you're writing a systems level thing, you need all those kind of optimizations to be present. When you're writing code for an enterprise, you typically want checks. Those milliseconds may cause your server to stop vomiting up errors all the way from the database up through all the validations that's going through, like a DMV check or something. So you always want to include these. You never really want to have, unless you have good reason, you don't want variables to be public. You always want to set them through a setter. Now, okay, the problem is, what if I don't want it to print and I just need to get it? I have a setter. Notice that I can no longer get the fake age. If I go over here and I say, let's print the fake age, all that does is print it. But let's suppose I actually need the value. So anytime I have a private variable where I need to get the value or I need to return it, so if I create a setter, if I make it private, the only way I can set it is through the constructor, which we'll do in a minute, or we have a method that says set fake age. Okay. So if I have it private and I have a setter, the only way I can get is if I have a getter. So now what I'm going to do is I'm going to say public void get fake age. Okay. And then I'm going to put this because we don't need to pass. I'm sorry, this is not good. Whenever we get the age, it's going to be an integer, right? So I'm going to say get fake age. We don't need parameters for that because we're only returning a value. And then guess what I'm going to do? I'm going to say return. Now, I want everybody to realize I could put fake age here. Why? Because there's no ambiguous resolution of the variable name. Fake age is the only one here, so what does it automatically default to? The one in the class. But what did I say? Always to be safe. You never know when you have a junior developer on the team that's learning Java or an intern or whoever else. This may make it much more clear about what's happening, especially maybe they're not even familiar with the language that much and they're coming up to speed with it. With you adding these comments and you adding comments to your code, adding these explicit things to show where things are coming from, sometimes it actually helps new developers learn how things work, right? So you guys are sitting here watching me code, I'm doing these things. If I just put fake age, it may take you a minute to realize that it's this one. Whenever I'm telling you that this dot something is referencing something in the class, it's immediate. So maybe you guys are learning from this, just like you would if you're a senior developer, add things in code to make all other junior developers come up to speed a little bit more quickly. Not only that, whenever you're working in a domain, it's very common for there to be millions of lines of code spread across millions of repositories. There's an excellent chance that people that don't even work for your company may start utilizing your code in classes for and people that you will never even meet, which means you have no idea how skilled they are through the contractors or whoever else, or if the company sells off part of its assets or if it acquires other ones, it's very possible that you may have people working your code that you'll never meet and you have no idea how competent they are in it. So anytime that you can do something to lessen the burden of a bug, that's kind of a cybersecurity implementation, right? Anything that you can do to prevent the incorporating of a bug, do that. Anything that you can do to prevent a bug, do that. Now there are trade-offs. I mean, you can go to the nth degree and end up causing your code to slow down, but just adding things like this dot something, the compiler's pretty much resolving all that anyway, and most of these extra things like that are getting chucked out, so you're not really going to cause yourself a lot of problems anyway there. Okay, some opinions. Those are free, no extra charge for that. Why does IntelliJ, I want to ask you guys this question, why does IntelliJ have this is blue and this is gray? The reason is because I've created a method that's not being used anywhere. So as soon as I go over here and actually use this, let's suppose that I just want to maybe print that out over here. I'm going to create a variable to where it says the age. How about that? We're just going to say it here. I want to get that value and I want to store it locally. I'm going to say my class, my sample class dot get fake age, and then what I will do is I'll do system dot out dot println, and then I will do the age. And then I run it, and you'll see that this will actually just print 40 twice there, because for once it's getting it through a getter from the class, storing it locally, and then it's printing out the local variable. So if we go over here to sample, notice that this is no longer gray because this method's actually being used. One of the powerful things about IntelliJ is it helps you to eject and erase code that's no longer relevant. You have to be a little careful though, because other things may be importing it. But if you see something that's gray, start looking if you could just delete it, because you may actually have used that before and it's no longer needed. And so to keep your code from being bloated with a whole bunch of unused methods, you just erase it. So you see where that's kind of powerful to use there. Also, let's suppose you're looking through here and you're like, oh, what uses print fake age? Guess what you could do? Click this, and if you do, it'll pop up a screen that says, oh, over here in Nathan class on line 7, notice right here, we're using that fake age. Notice right here, whenever I go back to one usage for increment fake age, it says it's being used here. So with that said, basically IntelliJ is so in tune with things. It's a very powerful tool to use. You can make Emacs and Vim do that very well. You also have a lot of people, if I could be maybe this may be a little bit insensitive, occasionally you have people that say, I only use Emacs and Vim simply because they want to be like the bourbon types, where they want to be kind of a connoisseur or something. And some people start developing like kind of maybe an overly grandiose self-image of themselves. They're like saying, oh, I must be the real thing in computer science, or I must be the real thing with respect to like a high-class developer because I use the terminal commands Vim and Emacs, and I can use the terminal as an editor. Well, in some cases we have to be a little bit careful, because just doing it for the sake of that's kind of juvenilistic. And the reason I say that is because super powerful tools, whenever you start having hundreds of classes and you have entire projects with like tens of thousands of lines of code, you may actually want to say, who is using this? Because maybe I need to make sure that I put the appropriate checks in there. Because if you're going to develop a method to where like it's going to be used by a team down the hallway, and you're aware that that team is typically maybe going through a high turnover rate, and there's a lot of juvenile or junior developers on the team, maybe you'll be like, hey, I need to add these extra checks just for the time being, or we'll figure out factor them out later. Having this tool to where you can actually see where something's used is super incredible, super powerful. VS Code does have extensions in it. The thing is these extensions that you download in VS Code, they tend to be a little clunky. Sometimes they don't work. Sometimes they're not even reliable because they're made by third-party developers that may not know the entire scope of how they'll be used. IntelliJ is so in tune with the Java development JDKs that since it's very specific to Java, it can make some very powerful tools. So, backing up, never be that person to say, I only program in one language because only the real developers use that language. That's kind of a very immature way of describing yourself. If you're in one area where you only do hardware development and they only do C and C++, that's a different thing. But if you're talking about somebody that goes through and not the only language that they ever use is one C, C++, or Python, those tend to be very juvenile type approaches. If you hear someone say, I only use Vim and Emacs, there may be a good reason for that. Maybe that is completely what their company uses. Maybe that is all that they need. Maybe they are completely working on remote servers where they have to do it that way. There's all sorts of reasons. If they're doing it just because for some reason they like to kind of believe that they're the real deal, then they're probably missing out a lot on life and they're making things a lot harder. And in a production environment, they would be considered very costly as an employee and they wouldn't be around very much longer. Corporations don't typically fire people. What they do is they just don't promote you and you end up kind of saddled in one place. And they're like saying, well, if you're going to sit here and be poor, then you'll quit on your own. Typically, that's what happens. Anyway, going back, we got classes. At this point, what you guys should be aware of is that we have public and private variables. We have public and private methods. What does private mean? A private method is only something that can be called by another function inside of the class. A public method can be called by anything outside the class that's initialize a class. A private variable can only be accessed by things inside the class. A public variable can be accessed by anything inside the class and outside of it. So public can be internal or external. Private is only internal. So let me show you an example. Does everybody agree that I have an increment fake age? What I'm going to do now is I'm going to change this to be clear. Does everybody agree that I am incrementing fake age here? What I'm going to do is I'm going to change this now to private. And all of a sudden you see what? One related problem. Let's click it. Notice that it's got a big red line underneath it showing that, hey, this is a problem. It says this has private access in here. Now, if you were to see IntelliJ kind of provides some methods and suggestions on how to do this. If you were to click this, you'd find out when I clicked this, you actually go over here and see that it made it public. By not having that there, it basically means public. So we're going to re-add this private here, and it's going to go back to a problem. And I'm going to say, you know what? Maybe I don't want to do that. Maybe every time I'm going to say public void increase age by 1. This is kind of a ridiculous code, but let's just do it. So instead of incrementing, I'm going to have a public method. Now, you wouldn't really do this because this doesn't really make sense. But what you could do is now you could call, this is the public one. Now you could call this one to increment fake age. And it's going to call that method. So what we could do is we can go over here. Instead of this, we're going to say increase age by 1. Notice that it resolves it. And whenever I print this, notice what's right here. We have 39, 40, 40. When I hit run, I still get 39, 40, 40. But the problem, the situation is that instead of like, whoops, did I misspelled that one? Sorry. Okay. So we go over here to the sample. We're increasing age by 1. But what does that do? It basically calls a method called increment fake age, which does this in place, which means it takes the local variable, does plus plus, which means increment it by 1, and then we print it and we see that it actually worked. So again, this is a ridiculous implementation without a doubt, because here this would have worked just fine. But we're just trying to demonstrate that this one cannot be called directly, but we can actually call something that could call it. Does that make sense? It's just for demonstration purposes. Okay, so the key things that I want everybody to be aware of, and maybe I will transition back over to my notebook. There's a few things that I want to make sure that we're 100% clear on. Is 1, avoid public variables. There's a reason we're using Java. We're not using Java to be a systems level language. We're using Java probably for enterprise level stuff. And allowing people to set public variables directly, unless we have a good reason and we know that they can't screw something up, is because you have no control over the values. You have no control over the values. So what do you instead do? Use getters and setters. So basically you define your variables to be private. Then you use setters to set the value. Whenever you use setters to set the value, that means that you can add checks to make sure that the person's not setting a value that may not be really all that relevant in the domain of your business, right? So if we're talking about an integer could be anything, according to Java, anything between that 2 point something billion and positive 2 point something billion. But we can't have somebody 2 billion something years old. So we need to put in their setter something that's going to restrict that. You can't do that when the variable is public. You can only use a setter to do that. Well, if the variable is private and you're using a setter to set the value, that means you can't get the value as a public value either. So what do you have to do? You have to use a getter to do it. So then you have getters and setters. So avoid public variables unless you are confident that nobody could screw something up. Otherwise, use getters and setters to control how you set and get public variables, or variables that are set to private. Okay, so we've got one more thing that we need to look at. Let's suppose that we have here, let's go back to the IntelliJ. We have something called a constructor. A constructor is effectively a constructor is basically a method to where everything that the class will need to do to get it up and running or initialized, that's what happens in the constructor. Okay, so let's assume that maybe whenever they initialize the class, let's say this, does everybody agree that here we had to declare the class, then I had to set the age, and that's what we had to do. So let's assume that all of this is just kind of irrelevant for right now. When I set the age in this method, I don't have a constructor over here. I do not have a constructor. I do want you guys to notice how some of these went gray because I'm no longer using them. But anyway, assume that you have no constructor in the class. You actually do have a default one. It's just one that doesn't have a body. So technically there is a constructor because whenever you're doing this, this is where you declare the top of your class, which you create something called sample, and this is going to be its top. It's going to be a class sample. This is the specific name that you're giving the instance to, and you're declaring new space for it. And then this is actually calling the constructor. This is actually the constructor of the class. Notice over here that I never actually created one. The reason is because this is actually what's happening. You actually have this being created by default. Notice that nothing's being complained about. So whenever I did not create this, whenever I never had this present, it was actually present by default because the IntelliJ JDK put it in there. It knew, the compiler knew that there had to be one because I'm going to be doing this to initialize the class by calling its constructor. Even though I didn't have one, it basically created one. That means it's one with no parameters and nothing in the body. Well, let's suppose that I want to say, okay, I want people to have the ability to just declare the class and then set the age. But maybe I feel like there's going to be times where like somebody wants to just declare the class and the age at the same time. What I can do is I can create another constructor, which is called overloading the constructor or overloading a method. I could say sample, and I'm going to let people pass in an integer called fake age at this point. So actually, this needs to be up here. Sorry. If I want to be very clear about it, this needs to be up here. So I'm going to have sample fake age, and then I'm going to do this. And I'm going to say, since they've passed in fake age, I'm going to let this initialize the value, and I'm going to say this dot fake age. Now I had to use this here because the parameter and the class name share the same thing. This is going to be fake age. So what I want you guys to look at is, let's see what this makes a difference. I want everybody to realize that this does not change, I want everybody to realize that this does not change anything that we had before. This does not change anything that we had before. Instead, though, maybe I want to do this one. I'm going to create a new class, and I'm going to say sample. Let's do it up here. I'm going to say sample, and I'm going to say second sample class equals new. And in this case, I'm actually going to pass in the age, which I'm going to say I want this person to be 41. Now, I want you guys to look. Whenever I declare this one, I can say print the value out. So I'm going to say my sample class dot print the fake age, and I'm going to, if you guys don't mind, I'm going to like comment all this out. Notice that when you have a class variable that has an integer, notice that this constructor right here is what's being called with my sample class. It's the one that has no parameters and no body because we're just using this one that gets created automatically for us. Okay, now the problem is once I create one that is not this simple one, I cannot assume that it's going to create that for me. So if you look here, notice that I no longer have a constructor declared. So once you declare a constructor and you want one to be kind of this trivial one with no body and no parameters, you have to keep it there. Once I create one, I have to have all the ones that I intend to use. So by me commenting this out doesn't mean that it no longer means that it's going to have that one created by default and we get an error. So once you create a constructor, you have to explicitly create all the ones that you will need. So now I have to, since I have this one down here, since I have this constructor, I have to have this one now for sure, since I'm going to use both of them. So this one is going to be like where it sets, but it initializes the class, but never explicitly sets the age. But look at what the age gets set to. Integers have to take on a value. They will take on the default value as 0. That's basically something we have to know. So it's printed out as 0. But watch what happens whenever I do second sample class dot print fake age. This one will print 41 since I actually had the constructor set it for me. So this 0 is coming from here because I never actually told it to do anything. I never actually told it to set age to anything. Since integers can't be null, they have to have a value. The default value is 0, and that's what it's printing out here. This one, on the other hand, this second sample class, it's the same class just with a different instance called second sample class. I'm initializing it by setting the age 41, and so when I do this one and I print the fake age, it's actually creating 41. It's actually printing out 41. So we have two different constructors. This one doesn't set anything. It just has to be present because I have another constructor. This one basically just makes the class available. So if you do this one, you have to have a setter for each one of these or else they're going to attain a fake value. On this constructor, when I call it, I actually pass in the fake age, and then the fake age becomes the initialized value. So in that case, I actually don't have to set it. But watch this. Remember how I said set age? Set fake age? If I wanted to, after I set it up, I could still call that setter second sample class dot set fake age, and then I could maybe put in the 123. Maybe I meet somebody, I want them to think I'm younger or something. I'll just click this. So the first time it prints, this will be 0, of course, because that's with this one. But this one I initially set 41, which is being printed here. Whoops, I need to print that. So let's do second dot print fake age. This one will say 23. So this is 0 because there was nothing set. This one is 41 because that's how the constructor was told to set. That's how we designed the constructor to do, set the age. And then this one resets it, and so we have 23. So maybe we want to say after we've already set it. So, I mean, could you imagine that maybe sometimes you don't want them to set the age when they initialize it? Okay, then you have to use set age. But let's assume that once the age is set, that they can't update it again. So what do? You just update your getter. You can never call the constructor again. That only gets done whenever you initialize a class. So maybe we could do set fake age. The first thing we're going to do is say this. If fake age is greater than 0, that means it's not the default value. Then what we're going to do is we're just going to say system.out.println age already set, and then we're going to make it return out of here. Okay, so the first thing it does, it's going to check set fake age means it's going to set, is the age already set? If so, it's going to say, okay, here's a problem, and then return, so we know this other code. If this doesn't happen, then it checks to make sure that the age is between the appropriate bounds. If it's not, then default it to 0, which means that they could reset it because this requires it to be greater than 0. Then we have this, sets it if everything's okay. Now watch what happens. I believe if I'm correct, this will throw an error and it will print out that the age is still 41. Notice that when we call this set fake age, it says age is already set, and then when I print it, notice that it never updated it from where I was at. Now, we could actually maybe have a problem where what if we all of a sudden want to undo it? Maybe I could do something like this. I could do dot set fake age equal to 0. What do you think will happen? Will that allow it or not, or will it complain? I believe it'll complain because it says the age is already set. Why did that not happen? Well, here's the problem. Which variable am I creating? Which variable am I referencing? See how these things can sneak in? If the class variable is already set, this is basically something else. This is what we're passing in. This is the class variable. Notice that we had a bug. Accidentally, I knew it would happen, but let's just pretend this could be a bug could actually happen. Instead of checking what the class variable was, you were actually checking what? The parameter, which is not what you wanted. So now we're going to go over here to main. By the way, whenever you're in sample class, notice that the green button is not present because you don't have a main function. When you're over here in Nathan class, you have a main function. So when you hit run, notice now that it's saying you've already got the age set, so you cannot even set it back to 0. The only thing you can do is basically just destroy the class and start over again by recreating a new one. That's effectively what you do. Okay, so that is basically the idea of a class that I wanted to show you. Let's recap just a bit. If you have a class and it has a main method that's labeled public static void with this parameter signature, then that means that you can run that class as a starting point. Whenever you create sample or another class, you have to declare it as a class, public class sample. IntelliJ does this for you. You have both private and public variables. Public variables are very dangerous because you have no controls on what people will do. And sometimes in your actual domain implementation, certain values may be out of bounds. You have both public and private. Methods. Private ones cannot be accessed outside the method, only by things internal. Public ones can be accessed internally or externally. Use getters and setters to protect your data and how things are encapsulated and to make sure that things fit your domain whenever they're setting values. And that's effectively it, right? That's effectively an overview of how we use classes inside of Java. So what I'm going to do is I'm going to basically push this out here to make it available to everybody. So way if you want to look at it on your own machine, you could download, you could get this code from the repository. Give me 1 second. And if you go over here to my repository, you'll see that when we click it, you'll create basically all this extra stuff. This is the folder where IntelliJ was working out of. Whenever you guys actually open up your IntelliJ, you'll first clone this to your local machine. Then you will actually tell IntelliJ not to open this folder whenever it brings it in your machine, but to open this one. You typically always want to point IntelliJ to open the folder that contains the first POM file. That's just kind of a general rule of advice. It doesn't necessarily mean everything always has to hold like that, but that's some general good advice. So I hope that the introduction to a class was very helpful. If you're from a C++ world, it's probably already very familiar to you. With all that said, hopefully you found this interesting. Hopefully you found it helpful. And I will see you guys at the next lecture video. So thank you for watching, and I appreciate it.